Okay, this is kind of a random thing, but it's kind of something cool. If you look up LLNL, the Lawrence Livermore National Lab, cannon. Lawrence Livermore National Lab, LNNL, has a very large cannon. It's a big gas gun, and it creates shock waves millions of times over atmospheric pressure in order to kind of study how large energy shock waves impact things. To do this, they basically take a bunch of gunpowder and pack it in behind their projectile and just explode it. And it just pushes the exploding gas, the expanding gas just pushes everything forward at a huge velocity. But from their site, if you look this up for their shocking gas gun experiments, if you take a small car cruising down the highway at 90 kilometers per hour and put its kinetic energy into something the size of an ice cube, that's the energy of a small projectile moving down the barrel. So I'm actually kind of curious, how much energy that is. So we're looking at the kinetic energy of the big gas gun. And so they say it's a small car. That's similar to a Ford Focus. So let's say that the mass here of the small car, let's say it's something like, just for number simplicity, 1,000 kilograms. It's like 2,000 pounds. Okay? And they say it's traveling at 90 kilometers an hour. So this thing's initially going to be at rest, but then its final velocity is going to be 90 kilometers per hour. So that's 90, and then kilo is 1,000. So 1, 2, 3 meters. Oh, that wasn't per hour. That is per hour. Ugh. Nobody wants to do per hours. Okay, let's convert that. Train track. Let's see. In 1 hour, there are 3,600 seconds. So this final velocity here, 90, 1, 2, 3 divided by 3, 2, 0. Okay, that's 25 meters per second. Okay, that's pretty quick. Pretty quick. Okay, so how much kinetic energy is that? Well, we know that kinetic energy, 1/2 mv squared. So this would be 1/2 of the mass of 1,000 times a velocity of 25 squared. Okay, so what would that be if we multiplied that out? Half of 1,000 is 500. What is 25 squared? 625. 625 times 500 is 312,500 joules of kinetic energy to shoot out of that gun. Now, let's put that energy into an ice cube and see how fast it goes. Ice cube. Ice cube. Make it cold. That's actually pretty cool. I like how that looks. Okay, an ice cube. Take this energy here and stuff it in that. How fast are we going to go? So, what, an ice cube has got to be something like, I don't know, for a nice ice cube, like you've got one in like a fancy drink or something like that, big cube. Let's just say it's like 100 grams, so it's like 0.1 kilograms, right? How fast is that sucker going to be going? Well, kinetic energy is 1/2 mv squared. And we know the kinetic energy. So let's say that 312,500 joules equals 1/2 of 0.1 times some velocity squared. And let's say it started from rest, so that's the final velocity. What would that velocity be? We multiply each side by 2. So 2 times that. And then we are going to divide each side by 0.1. We are dividing by a decimal, so this is actually going to get big real quick. This is going to become, 312,500 times 2 is 625,000. When we divide by 0.1, that's the same as like multiplying by 10. So we're going to get another 0 here, which means I got to move my decimal points around. Oh, 6 million. Holy cow. Equals v squared. And then if I want to get rid of that squared, we'll root each side here, which means, what is the square root of over 6 million? That's fast. The velocity of our ice cube is going to be 2,500 meters per second. That is quick. If you put that in miles per hour, holy cow. If you put that in miles per hour, just really quick little like Google kick, that is 5,592 miles per hour. That is how fast that their gun is kicking out. Speed of sound is about, or not speed of sound, what would that be in Mach? That'd be speed of sound, right? In Mach, yeah, that's speed of sound's about like 343. So 5592 divided by 343. No, not 343. 600 some. 5592 divided by, I think it's like 660. You get about 7. That's like 7.28. That's like Mach 7.28. That's how fast they're shooting that out. Mach 7. Holy cow. That is very, very powerful gun. Just powered with a lot of gunpowder there. But very, very cool. The gun is only 20 meters long, so it's 60 feet. That's just amazing. Crazy stuff at LNNL, the Lawrence Livermore National Lab. If you want, someday maybe you can go work there. Shoot things at Mach 7 down a cannon just for funsies. So that was just kind of a fun little kinetic energy exercise. But we'll leave it at that. Just a fun little thing. If you want to look that up, like I said, LLNL, Cannon, Lawrence Livermore National Lab. They do a lot of stuff there with shock physics and nova laser experiments, all sorts of crazy things for materials and pressures. So check that out.